organize this live event in order to bring reality to our courses and to connect with current challenges that can be solved using some of the models and techniques that you will learn in the supply chain courses as part of this program. My name is Eva Ponce. I'm the executive director of this program, and it's my pleasure today to welcome Dr. Mani Janakiram. Mani is the Senior Director of Data Governance and Analytics of Global Supply Chain at Intel Corporation. With more than 25 years of experience, Mani spent the last 20 years working at Intel and has led many different projects in supply chain, all of them very strategic projects in factory operations, capacity planning, process control, data analytics, supplier management, IoT, factory science, and many more projects. Today, we are fortunate to have Mani sharing his experience with us. Welcome, Mani, and thank you for joining us today.
Hi, Eva. Thank you very much. Let me go ahead and share my slides.
Yes, perfect. Before starting, let me, yes, 1 second. I'm going to share with you just the agenda for today. So the plan today is going to be, first of all, Mani is going to present how Intel applies supply chain network models. And at the end of this first part, what we are going to do is you will have some time for questions, live questions to our expert. In the second part, the next 15-20 minutes, Mani will explore how to manage the supply chain during a time of disruption and how to apply analytics to better manage crisis situation like the one we are living now today with the COVID-19 coronavirus. At the end of the discussion, we will have a chance for more questions. So please use the webinar questions and answer feature in order to ask questions. Be sure that you log in with your name. We are not going to read any anonymous questions. And we will also share with you a couple of polls during the event to better understand how you are dealing with these disruptions and learn more about everyone on the webinar today. Before starting, we want to better know you, so please answer the poll that should be live by now. Let's start learning more how Intel applies supply chain network models. So Mani, the floor is yours. Thank you so much.
Thanks, Eva. So before I get started, I hope everyone is safe and well across the geo. We are going through an unprecedented COVID-19 event, and hope that we overcome the situation. But think about it, right? When you look at what is happening from various aspects of whether it's a supply chain is coming in this central aspect of whatever we do. And whether, like we are looking for food or groceries or health, there is an aspect of supply chain that is playing, central to it. And then there's a question of how we can leverage the existing capability in terms of demand supply. That's where the models come into play. As Eva has indicated, I'm going to walk you through some of the capabilities we have, some of the supply chain models in action at Intel, and I'm pretty positive that it will be useful for all of you from various aspects of either effectively designing your supply chain or applying the models and analytics to manage your supply chain. But I would go to the next page and would start with where our Intel supply chain is in all this action. And I'm sure all of you or most of you know Intel Corporation, one of the leading and the largest semiconductor manufacturing company. And wherever there is compute, there is Intel, whether it is servers, CPUs, memory, you name it, right? With a lot of AIs embedded. And we also, from a supply chain perspective, we have a vast reach. Intel revenue is around $70+ billion, and our supply chain factors and touches every aspect of Intel business. We manage around $35 billion spend. So we have around 3,600 very talented supply chain professionals across the globe. And we have million plus orders. And so you name it, right? 1.8 units, billion units shipped. So there is a vastness and there is a complexity in terms of technology, and there is also like the velocity and the quality, all those aspects of supply chain is critical, which we manage across the board. And today we are talking about supply chain models in action. So I really wanted to start off with, okay, when you start looking at supply chain from a demand supply perspective, it kind of again touches everything that you know of within your company, whether it is a finance, whether it is sales and marketing in terms of forecasting, whether it is inventory planning at the customer level, at the product level, at the supply level, whether it is supply network logistics, or it's a product, material, construction, capital, anything that you talk about it, there is an element of what we call as plan, source, make, deliver, return that happens, right? And then there is a heavy dose of analytics. And on the left-hand side, that's why I'm kind of sharing with you the various stages of analytics. I'm not saying one is important than the other, but these are all critical aspects, right? The question might start with what is happening? Show me what's happening. That may be more like a descriptive, hey, what happened here? Why did our supply go down? That could be a diagnostics. And the moment you share some of these things, the next question that comes up is what is going to happen? That's more in the predictive space. And then the next question is, what is the optimal use of our resources? Or what is the optimal scheduling we can do? How do we balance supply demand, right? And then you start looking at the prescriptive or optimization part of it. And lately, like we are more into cognitive, trying to understand and learn from what our supply chain is telling us. And there is a heavy dose of natural language processing, the AI, the predictive models that are needed to go from data to information to insight. And as Eva has mentioned earlier, I am breaking my presentation into two use cases. One is around models for efficient and effective supply chain design, and the other one is around analytics for managing the supply chain during time of disruption. So kind of looking at what we are talking about in the models for efficient and effective supply chain design, I'll share with you how we are leveraging the models for optimizing end-to-end supply network for service level and inventory, whether it is make to order or make to stock kind of a scenario. I'll also share with you how to improve the operational efficiency. From an inventory perspective, we have different levels of inventory, particularly when we look at network, a multi-echelon inventory plays a big role. And then when we talk about capacity and output, how do we optimize that? And how do we minimize cycle time? And how do we optimize mix in our supply network? And another critical thing for us is the CapEx, or the capital equipment decisions. Intel, as I was mentioning, $70+ billion revenue, and our CapEx spends anywhere in the range of $15 billion. And in order to build one fab, it would be upwards of $4 billion. So it is critical whether we are building our own or supporting the ecosystem for a supplier. We need to be able to make the right decisions through running different scenarios. When to build, what to build, where to build, who we want to go build with, and what does the timing look like, and what would the projections, all those kind of criticalities needed. And then we will talk about like modeling end-to-end supply network to understand constraints and complexities in product supply chain. And also we look at design for supply chain that plays a critical role, particularly when we start talking about sustainability and things of that nature. And then we use the end-to-end supply chain models for what if scenarios and trade-offs. And we look at it across material, financial, sustainability, and information flows. So when we start modeling, there are different aspects of model that come into play. One is at a very high level, we look at the entire supply network topology, whether it's from a customer to Intel to supplier. Even sometimes we look at multi-tier suppliers. The whole idea is, do I know my supply chain in a way that I can not only operate, I can manage, I can run scenarios, I can reduce the risk that is involved, I can optimize my like capability to ensure that we provide the best to our customer. And in many different ways, if you look at it, supply chain modeling and simulation models are now transforming into what the industry 4.0 calls as a digital twin. The only difference I would say from my perspective, what's the difference between a simulation and a digital twin is simulation provides you what is particular supply chain look like. A digital twin kind of takes that, what a supply chain model look like, and connects that to the actual system so that now you have your ability to model, predict, and also operationalize what you're looking in as a business process. And you have heard of a digital twin that GE has talked about for aircraft engines, so that we can actually design them, we can understand where the performance impediments are, and then we can optimize and adjust. So that's exactly how I look at it. And then there's a question that comes up as, like I'm starting in this area as a simulation model person. So what is my, what approach would I take? So that's why I have a small cartoon in the top right. Normally, you would start with the metrics or the objectives. What is that I want to accomplish? What is the business objective? And what metrics am I going to measure? And then you're getting a better understanding of your existing network, your process is critical, because if you don't know as is, don't bother doing to be, right? And then once you know the as is of your supply network, you can build your simulation models. You have to make sure that you have the right data, you have the right, like a team, right talent to build it. And then once you're on the simulation, running scenarios, then that morphs into various aspects of, I can optimize my supply network so that my time to serve is lower, or cost can be optimized, or perfect order can be improved. Those are all the kind of things you would look at. And it is very critical that you don't build simulation and optimization models in a black box mode, right? Because you want to pull in your stakeholders, you want to pull in your users, and then you probably make them super users. That can be done through interactive visualization and dashboards where they can actually engage in running the model, looking at the end results, maybe even looking at different scenarios and trade-offs and things like that. Once you get to the level of competency that the models are actually representing what is happening, and it is helping you with scenarios and, for that matter, operational and CapEx kind of decisions, you can put it to pilot use, and you should integrate it in a way that you can leverage it. So the question comes up as to, how do you do this architecturally? What I'm sharing with you at a higher level are different aspects of data and logic and analytics that go into building an end-to-end supply chain simulation model. At the bottom is what I'm sharing, what a supply chain network look like from a semiconductor perspective. You have fab operations, you have die prep, you have assembly test, you have warehouses, and then it goes into distribution centers and then onto the customers. And there are different types of models, as I was mentioning earlier. One can be at the highest level, where we're looking at the supply network end to end. The other one could be, like more at the factory levels, where we want to optimize the factory output. We want to understand the constraints in the factory. We want to understand the cycle time. We want to understand the mix. And that can be a deep level, a deep down factory model. You can think of it as more of a network of network models that are integrated so that the information flows at the highest level to show you how your supply chain look like. In this case, for example, the data that goes into the supply chain includes demand data, supply chain data, like supply data, like capacity and everything, environment, and all those kind of data goes. That's what we're collecting, and goes into your data preprocessors. And then we have automated scripts. It can be Python, it can be R, it can be SQL, you name it, right? It can be the one that you're comfortable with. Could be Java, right? And then we can either automate it to run the simulation and then provide the inputs, or it can be user triggered. And then the input data gets pre-processed, and then it is very important, depending on the type of software you're using. The type of software that's available in the market could be AnyLogic, LlamaSoft, could be, like various other aspects. If you get into the factory level details, it can be Extend, it can be AutoSCAD. Various types of softwares are available, and they have unique capabilities where you can develop modules. And then, but you also need to understand what the input files should look like, and whether it is a start file, whether it is a product mix file, whether it is a process flow time, whether it is the output, and all those details need to be, like developed and put together, and then you feed that into the simulator. And most of the time, depending on the size of the simulation, it can be from seconds to minutes to even hours, depending on how many runs you're making, depending on what the complexity of your simulation network is, and all kinds of stuff, right? And then once you run it, the simulation, like you normally run several simulations, because the beauty of running the simulation is, what we, you can do a discrete event simulator, but you have to be careful about running it just once, because you need to run the simulation many times over, maybe hundreds and thousands, so that you get, like the stochastic variability in the picture, so we can look at the ranges. And once you have the simulation output, that goes, we kind of feed that into a simulation database. And talking about visualization, we feed that into our business intelligence tools. It can be Power BI, it can be any of the Tableau or any of those things. And then we have automated to the extent that we have the web reports that the users interact with. And this is more like an architecture that enables an end-to-end supply chain models. And I want to kind of share with you how a model would run. And in this particular case, it's a demo. We have taken a particular supply chain network for a product. Of course, they're all masked. I'm calling it as fab and OEMs and things like that. But what you're seeing is the interaction that happens, the relationship, the data that moves in, and then the output that comes out of it. In this particular case, we are looking at various levels of inventory. We're looking at service level. We're looking at different operations at different levels, because particularly if you're dealing with a network, the multi-echelon inventory, as I was indicated, is critical. And that means we got to be looking at where the constraint in your entire system is, and what kind of an inventory policy you're going to have in place, and how do you make sure that you are hitting the service level at various aspects. And things of that nature is what we are looking at. And then we also gone ahead and we looked at what does it mean from a overall cost perspective. What is the inventory cost? What is what does the service level to inventory kind of trade-off happens? Those are all the different things we have done, and I wanted to share that with you in this particular slide as well. And it is also important when we build this kind of models to provide a user interface, because one approach is the users would say, I want to run this model, and the simulation that, like a combination of operation research engineers, data scientists, data engineers, get together with the business subject matter expert, pull the, like the entire network topology, build the model, run the model, and then share that with the users. Or, once the level of sophistication from the users goes up, the best thing would be to develop these dashboards and also these interactive UIs where they can actually go and run different scenarios. In this case, for example, it is a multi-stage network where we have multiple suppliers involved, multiple warehouses, and there is a question around what is the lead time that we need to plan for different bill of materials, and then what is the manufacturing lead time, what is the service level, what kind of a vendor managed inventory DOI targets we should have. So that way we can also monitor, run it, and see what works best for you. And we have also have an ability to run different scenarios in a batch mode, collect that information, apply optimization, and using data science, we can come and say, this is probably one of the best you can select given this current situation, right? Those are the kind of things we do. And the question that comes up is, how do you actually make decisions based on running the simulations? What kind of trade-offs are involved? And I was mentioning earlier about the trade-off across material, financial, information flow. This is another example of how we leveraged simulation for making those kind of trade-offs. And in this particular slide, we are looking at service level versus cost. For that matter, we are also able to put the revenue to see at what service level, what's the optimum service level, and what would be the ranges that we can go with, and what would be the implication if you're committing to a service level that we are not able to accomplish. And then the other question that comes up is, in your entire supply network, where should I focus? I mean, some people would immediately say, yeah, go focus on the forecast error, right? In some cases, it may be a contractual obligations, it may be a particular raw material that is critical. So we kind of model that to understand what is driving our inventory, what are the liabilities that we need to have in our entire supply network, and what impact. This particular slide is basically showing where we should focus. What is the like almost like a chart where you're looking at what is a negative impact, what's a positive impact, and in what order they are kind of representing. It's almost like a regression kind of a model, right? Those are the kind of things we can draw out of this simulation. So that was part one of my discussion. So Eva, do you want me to continue to my second part, and then we'll take the questions at the end, right?
Yes, thank you so much, Manny, for sharing with us the how the supply network works, and also the end-to-end supply chain simulation modeling, how it works at Intel. I think we have a couple of relevant questions for you. I can run these questions now before we move to the second part. That's okay for you?
Absolutely.
Awesome, great. So the first question we have received is from Adi. And Adi is asking if you think about what Intel has done in terms of modeling, what do you see achievable for a small and medium enterprise? What tools would you recommend for this small and medium enterprise, or would you more recommend to use third-party consultants?
Absolutely. I think that's a great question, because not every company or everyone, will have the kind of talent and the capability that we may have. But every one of them have problems, right? Every one of them have intentions to have the best supply chain that they can. And that is independent of the size or the location or the product or the service, right? We want to do the best for the customer. We have to make sure that we have, do we understand voice of the customer? Do we have voice of the process that enables it, right? So, and the metrics are not going to change, whether it is a customer facing metric, factory facing metric, supply chain, right? So I think understanding and recognizing that the problem is not unique and is number one. And then the next thing is, what metrics matter? That is one of the critical things that anybody should be looking at. How the performance of our company is measured, revenue, cost, customer satisfaction, just to name a few, right? From a supply chain perspective, that could be order fulfillment lead time, that could be perfect order, that is cost of doing the business, cost of supply chain, or how well the assets are utilized and how they're connected to the financial, whether it is a ROI, or it is ROPAR, which is basically based on physical assets, or is it based on service, right? So understanding that metrics and then looking inwardly at what we can do with what we have. I mean, you can even start off with Excel for all you know, right? Because if you have the right questions, and if you can connect the right people who are asking the question to the right metrics, and if you can figure out what data really matters that I can go pull from, you have to have data somewhere or the other. The question is, in what capacity can I have it? Is it in, like an Excel database, or is it in a sophisticated SQL database? And that we can, have enterprise systems that are connected. So there are different modalities that you need to look at. So asking the right question, understanding what the stakeholders want, what the metrics matter, and then what data is required would be, like initial stages, and then you can apply. There are, like Excel, there are a lot of open source applications that are available. like NIME comes to my mind. And then there are so many others that you can actually go leverage. Even within the Python library, you can do a lot of data science applications and in R. And so those are the kind of things you could actually take advantage of, build some of these models, stochastic models, predictive models. And from a simulation perspective, I know that a couple of people have actually built their own version of supply network model using Python, open source. So there are different ways you can do this, but the level of sophistication and as the complexity goes up, these models help us build faster because time to solution is critical, and ability to flux and change some of the things we want to do so that we can build once and use it many times. That's where these kind of capabilities that we have comes, very handy.
Excellent advice, Manny. One question from Geoff. He's asking, do you tend to rely more on linear programming models, optimization models, or on Monte Carlo simulation models?
And each one of them have a different role to play. Monte Carlo primarily considers the variability, the stochasticity, right? Because you never want to give one answer to a question. What is going to be my output? You are never going to be right by saying it's going to be, let's say, 2 million. 2 million plus or minus something. What is a plus or minus something? That is where the variability comes in. That's where the Monte Carlo simulation plays a real good role. Because when you start stacking things together, right? I mean, I was showing you a supply network. Each of the nodes in your network has a certain variability associated with it. And if you don't understand that variability, for example, in Excel model, you have to really put an average for that. And that's where a discrete event simulation model that incorporates the Monte Carlo and the stochasticity comes out with a better range. And then the other comment was where would you use optimization, right? Primarily, the way I look at it is different stages in your supply chain analytics. As I mentioned, when you're doing some predictive kind of models, the Monte Carlo kind of helps with the range forecasting. But it also gives you a outbound range, inbound range for it. But the optimization, on the other hand, tells you what is the best I can do with what I have. And then even in optimization, you could do deterministic optimization, that is linear programming, or you can do stochastic optimization that involves, like response surface models and design of experiments, where that kind of takes into consideration the variability in a much better way.
Excellent, excellent answer. Yes, this connect with a Sajid question. He's asking what specific models are we teaching in our program? So Sajid, for instance, linear programming models and Monte Carlo and simulation techniques, we are teaching these models in supply chain analytics, the first course as part of the program. In supply chain design that will start this June, we teach network design tools based again on the linear programming models that Manny is presenting today in order to optimize the logistic cost of these networks. In SE4X, in supply chain technology and system, you will learn more about machine learning techniques, big data and data analytics and modeling. So this is something that Manny is going to cover now and is going to show to us and share with us how Intel is using data analytics in order to handle a crisis situation like the one we have now during the COVID-19 coronavirus. So let's move to the second part now, and I will try my best in order to bring more of your questions at the end of the presentation. So Manny, let's move into the second part.
Thanks, Eva. So the second part, as Eva, you were mentioning, it's all about analytics for managing the supply chain during a time of disruption. But before we jump there, I wanted to kind of share with you how we are leveraging data, converting data to information to insight, and what are the different modalities where we get the information or the data from. Like, for example, we leverage IoT to get some of this data. And most of this data is becoming, like almost like a big data, not just because from a volume perspective, but also from the velocity with which we want to respond to the questions, as well as the variety of the data. The days have gone where, like 70, 80% of the data was structure. Now we are dealing with unstructured data and hybrid data. It could be coming in the form of text and things like that, particularly when you're looking at supply chain risk and ecosystem sensing. We need to be able to capture those. We need to be able to convert those into meaningful insights. And so that's where, we can also looking at actionable analytics through interactive dashboards, predictive AI and machine learning kind of capabilities. I will also share with you supplier insight, intelligence, and proactive risk management using cognitive AI and ML. And we will talk about some of the current situations as to how we are applying this. And before I get started on this, once again, what are the basic components of analytical solutions? Here, you can look at it as we got to have data, or you got to have a semblance of data that you need so that you can do the integration and then you can understand what the data is telling you. And then, of course, you have the data, then, you apply analytical models. To earlier question, it can be different kinds of modeling techniques, whether it is simulation, optimization, heuristics, different kinds of things. And then, of course, visualizing it is more critical because doing analytics in isolation is not going to help anyone. So a display of models result in meaningful way for our stakeholders is something critical. I also outlined what type of skill sets are required, right? I mean, when you're looking at data, subject matter expertise is critical. Data integration and data engineers do most of the heavy lifting there. In the analytical models, we're talking about data scientists, and they need to know where the data is. They need to be able to manage the, database and tables and queries and things like that. And then, of course, visualization is human factor skills, data engineering, data scientists, those, and then understanding what the business folks are looking at. Those are some of the things that are critical, but don't forget that none of this matter if you don't understand what the business problem is, or if you don't know how and why these analytic solutions are enabling the business, because understanding the business problems is critical before you do anything, and ensuring what you do provides value significantly is another critical aspect. With that, I wanted to share with you some of the capabilities that we have, and I'm calling this as the end-to-end predictive visibility. I want to underline the predictive piece of it. And I was sharing earlier about our factory network. Now you're looking at fab, sort, die prep, assembly, test, manufacturing, warehouse, and the VMI. And I just want to take a subset of this network to show how we monitor, manage, and stay ahead of what is happening through predictive visibility in this particular section of our network. Going to the next page, the piece that I had is what is represented as the fab and assembly and warehouse. And with the help of advanced analytics, primarily leveraging time series models, using machine learning and visualization, and also even using control chart kind of a capability, we are able to look ahead how our metrics are going to behave. In this particular case, we are looking at various components and their availability. And we are looking at safety stock and days of inventory. And then we are kind of modeling scenarios to see where and when a particular component could be, a short supply. This is the same thing that can be applied to our product level where we are monitoring availability. So you can actually decide on what metric you want to measure, and then accordingly, the predictive visibility works. And then if you're monitoring thousands and thousands of these components or products, we have the ability to visualize them using the heat map contrast, and then we can look at the cluster of activities going on. We can drill down to see exactly where there is going to be a potential failure that we can operate. And if you know where this is going to be a problem, through our visibility, we will be able to take the corrective action. And this is, in fact, I think if you were to go look at the journals and periodicals or talk to any of the supply chain professionals, they would say visibility is a number one priority for supply chain leaders today. And that's where our focus is to provide end-to-end visibility for proactive alerts. This saves millions and millions of dollars for us in the product component and spares. And the second example is more around understanding our ecosystem, and so that we are staying ahead of the game. And it could be, market intelligence, it could be material intelligence, it could be supplier intelligence. And Intel, we are very big on corporate social responsibility. So we want to make sure that our suppliers and our tiered suppliers are also, are practicing the right corporate social responsibility. And those are some of the things, the questions that are listed here are just an example or illustration of what are the different things we can handle. And I want to take you to the next slide, which is a demo of our forced and bonded labor. We are monitoring our suppliers to ensure that our suppliers are free of any of these challenges. And on the bottom right, you could see, different things that we are modeling, or rather we are looking at. And the data for this is coming from various external sources, available data, as well as some of them may be subscribed data, but it is curated in a way, and then we apply natural language processing, and then we apply the cognitive learning to understand where and what is happening. And we also want to make sure that we are sourcing the information and the data from various angles in order to eliminate any fake news. And we, triangulate it, and then we also have translators that can pull information from various geos. And in this case, we are kind of looking at different aspects of, kind of sharing, what is happening. We're tracking different capabilities. And in this case, we are looking at cobalt sourcing from Republic of Congo and who the suppliers are. And are these suppliers free from the corporate social responsibility issues, primarily forced and bonded labor, trafficking, modern slavery, and things like that. And this information is very helpful for our supply chain professionals, whether it is a buyer, commodity manager, contract negotiators, to really understand where and what to do. And this is one of the things that we leverage. And so, like this, like it enables us to really proactively look at our business continuity. And so kind of talking about what is happening right now. The analytics is driving our business agility. In terms of where and what we are doing, whether it's a peacetime or a wartime, we have to understand and be ready for what is happening. We should have the right set of metrics. Within our supply chain, we call it as SQUADs, safety, cost, quality, availability, technology, sustainability. We need to be able to know what is happening. We need to be able to know what's going to happen. And that's where our advanced systems through the analytics is helping us. And then using the ability that we have and the skill sets, we are also engaging and committing to embrace change, whether it is a strategic engagement or talent readiness. And then, like when it comes to what's going to happen in terms of the wartime, we are ready for it, whether it's in peacetime or wartime. A predictable, transparent, and prepared supply chain plays a critical role for our business agility. And kind of switching gears a little bit here and kind of talking about how what we talked about, the models, the scenarios, the analytics, how is it helping in the current situation, right? So from the COVID-19 perspective, I'm sure most of you are doing this. This is our perspective of what we are doing, right? From a workforce safety, from product and services, and from delivery. Like adapting sourcing approach to secure constrained masks, and evaluating options and scenarios, working closely with governments and suppliers, and understanding what the like things that we need to do, and then of course adhering to the safety protocols. And then when you look at product and services, it's very critical to have like business continuity plans in place, like leveraging our existing emergency frameworks, and then primarily ability to respond rapidly, and then ability to model different scenarios. This is where the models can come really, really handy. And we should be able to go from model to virtual solution to really look at what it means. And and then looking at trade-offs. And what I was sharing earlier in terms of sensing and ecosystem come into play in terms of, what is happening when it happened in a particular region, what are the different waves, and what it means for our employees, what it means for our customers, what does it mean from our product and services, what are the different things we can do from a delivery perspective, and some of the, like a capacitated challenges, whether it is charters or it is demand supply alignment or adjusting our needs from a customer perspective and providing better visibility and trade-off are all the kind of things that we are handling from a scenario planning, advanced preparation, rapid mobilization, and coordinated actions are some of the things that we are leveraging to manage our current situation. So that brings me to the question that you'll be asking, and I want to leave that with you, is what can you do today to prepare? And primarily, I want to bucket it as like a three different things or three different tenets, right? One is the mindset. It is very critical to think positively because there are a lot of things that are happening that can push us down into the spiral in a downward fashion. We got to have positive mindset. We really have to be focused around customer. From our perspective, we need to be looking at how do we enable the customer, whatever the conditions are. And then it is critical that we have a data-driven decision mindset because there are a lot of thinkings, like that comes around. Some of them are good and some of them will enable data-driven decision. But if your mindset is, I'm going to leverage data, I'm going to leverage logic and analytics to drive my decisions, that helps. And leadership plays a very critical role, right? The commitment, doing it the right way, and like ensuring and enabling the right set of talent is involved, and then collaborating proactively so that we are not left behind is very critical, and leadership plays a role. And not to mention the continuous learning is critical because if you do once and then if you go away, you come back, you forget it, right? That's where the building your muscle memory comes into play. That's where several of these capabilities that we're building and having people to leverage, like analytics helps. And also we want to lift everybody's capability through data fluency so that they can all be masters of their own domain and apply these kind of skill sets. So in the, I would say that leveraging analytics, learn today, implement tomorrow, and prevent future threats is where all of us can go together and counter the current scenario. With that, I'm going to come to the end, Eva, and I'm ready for questions.
Excellent, Manny. Thank you. Thank you for that insightful presentation. I'm afraid that your presentation has generated a lot of interesting questions. You already answered some of those, especially those related about how Intel is managing the disruption. You already covered that, and how supply chain analytics drive the future. And you mentioned that. You said, hey, supply chain analytics is helping your company to be more agile and drive this agility that is totally required now. So great job with that. Before moving to the questions, I want to run a second poll in order to hear a bit about what our audience companies are doing in terms of the coronavirus. Then we will discuss a bit the results. So Manny, some of the questions I have received, I want to share with you. Mm-hmm. One question from Amit, he's asking, what is making difficult for companies to achieve supply chain visibility?
Great question. As I was mentioning, visibility is one of the number one challenges that people face in supply chain. And what is making visibility difficult is number one, are we asking the right question? Number two, are we getting drowned in data and business processes that we are not able to have a clarity around what is that we're looking for? So this is where having the right metrics, having the consensus around who the decision makers are, who the stakeholders are, what questions they're answering, and in what fashion they want to answer. So almost having a markup of how you would like to leverage the data to respond to it. And if you don't have that clarity, everything else is a cloud around you. So that's where we spend the time in understanding, like walk in their shoes, if you will, to understand before we go solve a problem. We want to know what is that you're trying to solve. And sometimes it is an exploration because not everybody have answers, right? So we work with, okay, this is where, like you could leverage maybe your Six Sigma, process consultants to really understand, do we know what is happening? If you have clarity around what's happening, do we know how, what success look like? What does good look like? What's bad look like? And then, like where are the hinge points that you really want to have visibility? And then maybe you can go focus around that in what way you want to consume it. It may be an interactive dashboard. It may be an email that comes to you that tells you there is something going on. So those are the kind of things. And it may be down to at the, in the future, it may be more like ask your supply chain. You can ask a question and that would tell you, more like a bot, right? So there are different ways you can look at it.
I really like your approach, how to leverage the data in order to answer that question. That's totally right. Okay, one question from Yusuf. How has the recent pandemic affected supply chain models and analytics?
That's a great question again. I think there is with the COVID-19, there is a rapid awareness of what we can do quickly using data models to look at different scenarios. Because everything we are doing here is to provide the best response, whether it is to our employees, to stakeholders, or customers. And then we have different options that we can do. So in our look at the options, we have to do a trade-off. And in order to do the trade-off, you got to look at the scenarios. And that's where the models come in. The models can be more like, oh, based on my expertise, this is what we have done. That is more like, like you can think of it as a human cognitive engine mentioning it. Or that could be, if you have this kind of a risk that we have to deal with, we can model it and we can predict that this is what we can fulfill. That's a predictive kind of a model. Or given this capacity constraints and then, like a lane restrictions, this is the best we can do in this condition, that is optimization. So it all comes down to how we are applying it to answer different questions, but don't forget that it has to be in a consumable fashion, in a visual, like a dashboard where they can leverage it.
Great. So Manny, we asked the audience about how their companies are reacting to the coronavirus. And I want to share with you the results. So we have that 60% of them said that they are shift work to rotate, minimize on-site staff. Then we have 33% that they are creating a customer product priority plan. They are also creating emergency management center to manage the crisis, maximizing free cash flow. These are kind of the most voted answers.
That's pretty good, actually.
Yes, this is very interesting. And we can run now the third poll about to learn more about what they are doing. I have also a question more related to how to manage the data and how to clean the data, because we know that cleaning is also a very important part of the process and is very time consuming. So Giuseppe is asking, after clean data, how you assess in the choosing process in order to pick the correct tool to model and analyze data. Not an easy question, Manny.
I think, you got to start with the mindset of what you have is going to change, or it's, like when it comes to data, either you don't have data, or you have too much data, or you have data that you cannot, you cannot trust. So these are all the situations you're going to have, but we have also built our ability to look at what we have from what is available. And that is where, from a data cleansing perspective, we really look at, I was talking about the ecosystem sensing, just kind of going to that one. The question that always comes up is, in the era of fake news, if you were to go pull something, somebody says this supplier is having an issue financially, or whatever. And then if you were to provide an information that is not correct, or if you're going by the supplier's ability that is being reflected may or may not be right. So what we do is we have to make sure that you have alternate sources of data for, in this unstructured, and then you have to make sure it is verifiable data. That's where we have to make sure that where the source of data is coming from. And then you have to triage it so that we have enough information. And then not to mention, we also have to go back and check a more like an auditing function to make sure that, hey, is it right or wrong? And the other question was, how do you cleanse the data? You have a lot of data, we don't know which one to use. And it's kind of interesting that there is a lot of data cleansing capabilities that have come up. And in some cases, the whole purpose of data lake is I have different variety of data that I can put it in there, and then I can build models to see, like whether, it's almost like a sniff test or a gut test, right? I mean, if the model comes and tells you, for example, that you can provide 95% service level, and if you were to run this by a pool of experts, they say that we have never crossed 80% service level. What are you talking about? So that is where the validation and verification of your, number one, do I have enough checkpoints to make sure the data is right? In fact, sometimes 80% of our code is checking to see if the data is good, and 20% is more like collecting data, for example. The same thing goes for logic as well. Like we have to make sure that we not only verify, but validate what the model is telling us. And that way you have to gain the credibility before you start, leveraging the models.
Mm-hmm. Excellent. One question from Jorge Correa. He's asking, do you think that this COVID-19 situation will affect the research and development budget of the companies and adjust the focus to the emergency and operational relief?
That's another great question. I think it depends on, again, the mindset and leadership of the companies. Some companies try, like basically look at, this may be a great opportunity for us to build the infrastructure. And some companies may go back to basics and say that, it's almost like I have to go back to my survival mode, and then I have to build and then come from there. So it depends on the culture and the strategy they have for the business strategy that they have. So I don't have a specific answer as to what people would do, but again, it depends on their business model. And I would think that there will be some pushback and pullback in, pulling into, okay, you know what, let's go strengthen it. Because if you don't have the cash cow, you don't have the, like the incentive to go the next product, right? So it depends.
Mm-hmm. We also asked the attendees what they think this disruption is going to change how the company operates their supply chain. 46% of the audience said that they believe that it's going to be a greater focus on supply chain, a higher focus on supply chain than before. Some of them also believe that digitally enhanced supply chains, diversifying suppliers, and more local domestic sourcing. What do you think about these results, Manny?
I completely agree that the supply chain is going to change based on what we are experiencing. I think one of the critical things that we need to be really looking at is our reliance on supply chain based on geo. We need to be looking at where our critical constraints in our supply network is. And then instead of entire globalization, is there an opportunity to look at localization? And localization, as like is the word coined many years ago, primarily, like when you're planning, you're looking at what the best you can do across the globe. And then you look at your criticality in supply chain, whether it is a product, whether it is being closer to the customer, or whether it is something that is critical that I cannot outsource. So that's where the localization comes in. So having that capability of localization is probably going to be much more intense. And like the supply chain will definitely look at like location dependency. We'll look at sole source, and we'll also look at like closer to the factories or closer to customers, and also the inventory as we see the buffering strategy, we need to be looking at it as well. So those are some of the things that will most certainly will change from my perspective.
Yeah, fully agree with you. And the last question, Manny, what are some of the supply chain management skills and capabilities that you need now more than ever?
I may be biased here, but I would say that data and analytics is going to be very critical going forward because we are in the data-centric world. In fact, I would go forward and say we are in the information-centric world. And because you mentioned earlier about digitization, there is going to be a heavy emphasis on digitization. And it's not just automating things, it is about learning from what automation tells you. In fact, I've been kind of looking at where our journey is going to be. Basically, I'm focusing on what's called as the autonomous digital supply chain. So, which is primarily, where the industry is going, could be several years from now, just like the automotive industry having, like migrating towards the autonomous. I believe there is a great opportunity for leveraging data analytics and transforming to a digital world, which is going to be much more visible, much more transparent, and much more, nimble.
Excellent, Manny. Thank you. Thank you so much for this great presentation. If you want to learn more about our supply chain courses, if you want to learn more about data analytics, as Manny recommended us, just do not hesitate to contact us to enroll in any of our courses. We have supply chain analytics, supply chain design, supply chain dynamics, supply chain technology and systems. So a broad option of different supply chain management topics. Thanks again for joining us today.
You're welcome.